All right, you are welcome back to our physics class. We have this question to solve and we have this circuit diagram. Then this question follows. The effect of closing the key K in the circuit shown in the diagram would be to dash. Then we have these options. When we have the question like this, what they really want us to understand is that they want us to know, they want to detect whether we really understand the concept, close the key and open the key. And don't forget, another word for key is the switch. So just like the switch we have in our various homes where we on and off our bulbs. So when you close the key, so what you are doing is that you are completing the circuit and allowing current to flow across. Then when you are opening the key, then you are terminating, you are breaking up. So therefore you are excluding that particular region, that particular area or that part of the circuit. For this question, we try to calculate the amount of current that will be required to move around the circuit if the key here is to be closed. So then we calculate when the switch, the key is to be opened, then we'll find the difference. So the difference will now determine our answers. So using our Ohm's law, V is equal to I R, then our current is equal to V over R. Our V, don't forget, my V is equal to 6 volts. The 6 volts is here. My R, resistance. My resistance, I'm considering closing the key. Closing the key now, we are considering the resistor here, resistor, and together with this, it means we are allowing current to flow across this particular portion. The current will flow across this portion also. So therefore, we have 8 ohm in parallel with this 8 ohm. We have equivalent resistance given to be 1 over half. It's equal to 1 over 8 plus the 1 over 8. LCM is 8. 8 in 8. That is the 1. 1 multiplied by 1. 1 plus the 1. 8 in 1. That is 1 again. 2. That will be 2 over 8. Therefore, I'll have my 1 over half to be 2 over 8. If you do that, you have 2R equal to 8. Then divide both sides by 2 by 2. Therefore, our half equal to 4 ohm. So remember, this is the equivalent resistance of this the two resistors here. The equivalent resistance will now be in series with these 2 ohm. So therefore, my RT, that is total resistance, now will be 4 plus 2, which is 6 ohms. Then I'll continue with the calculation of I. Let's assume this is I1. I1 will now be 6 over 6, which is 1 ampere. 1 ampere. 1 ampere means that the total amount of current that will pass through this circuit together with this circuit, that's 1 ampere. But for this circuit alone, that is when this particular guy is open, then we have I2 is equal to our that is a V over R. That our V is 6 over the half. Remember, we are leaving this out. We have 8 ohm in series with 2 ohm. That will be 10 ohms. That will be 10. That will be 2.6 amperes. 2.6 amperes. So when you find the difference, so I2, that will be I1 minus I1 minus I2, that will be 0.4 amperes. So it means if you are closing this key, so a total of 1 ampere will be needed to flow across this circuit. But if you are closing it, if you are opening it, that is, if you are leaving it out, so that means a total of 0.6 ampere will flow across this particular region, this particular circuit only. So therefore, if you want to close this circuit, that is, you want the current to extend itself to this particular portion, you have to add 0.6 ampere to the initial 0.6 ampere that was there. That means the option D is the correct option, that is increasing the current by 0.4 ampere. Thank you very much for watching.